Hi. So we've looked at how to differentiate a function when it's a combination of other functions. That is, if it's f plus g, where f and g are two different functions, or when it's f minus g, then you differentiate f plus differentiate g. If it's the subtraction, then you differentiate f minus you differentiate g. Okay, so we'll be looking at functions of the form f times g. This time it's a combination of two functions, but the operator between them is a multiplication or the product. Okay, so what you use here is called the product rule, because it's a product of two functions. And the product rule says that y prime, which is the same as dy dx, is equal to keep one of these functions constant, differentiate the other, plus differentiate what you kept constant in the first part and keep constant what you differentiated in the first part. Okay, so if you're keeping the first function constant, it means you're not doing anything to it. So we have f times differentiate the other function. If you differentiate g, we get g prime, plus now you do the reverse. So you keep g constant times you differentiate f. Differentiating f, we get f prime. Alright, example is if y is equal to x squared times sine x, then dy dx is keep one constant. So if you keep the first function constant, it means we have x squared times differentiate sine x. If you differentiate sine x, you get cos of x, plus you do the reverse. Keep the second function constant, sine x, times you differentiate the first function, 2x. So if you simplify this, we have x squared cos of x plus 2x sine of x. Another example, if I have y is equal to cos x times sine x, then dy dx is equal to keep this constant. So we have cos of x times, if you differentiate sine, you're getting cos x. Alright, then plus you keep this constant, keep sine constant, so sine x times you differentiate cos x. If you differentiate cos x, you get negative sine of x, and this is equal to cos squared x minus sine squared x. Alright, so I want you to try your hands on y is equal to cos of 2x plus ex sine of x. Alright, now what if the function is in a fraction form? If y is equal to f over g. Now since this is in a fraction form, to find dy dx, then we use the quotient rule. And the quotient rule is keeping the denominator constant, so g, differentiate the numerator f prime, minus keep f constant and differentiate the denominator all over the denominator squared. Alright, so this is more like a combination of the product rule, the sum rule, and then the difference rule. You keep the denominator constant times differentiate the numerator, minus keep the numerator constant times differentiate the denominator all over the denominator squared. Okay, so if y is equal to tan x, then tan x, we know under trigonometry, is equal to cos of x all over sine of x. Okay, so we want to differentiate y is equal to cos of x all over sine of x. This is in the quotient form, so it means the y dx is equal to keep the denominator constant, so we have sine of x times differentiate the numerator. If you differentiate cos x, you're getting negative sine x, then minus Okay, keep the numerator constant, so we have cos of x. Differentiate the denominator. If you differentiate sine x, you get in cos x all over the denominator squared, so sine squared x. This is equal to negative sine squared x minus cos squared x all over sine squared x. Okay, now there's a common factor here in the numerator, which is -1. So if you pull out -1, then you're left with sine squared x plus cos squared x all over sine squared x. But sine squared x plus cos squared x is equal to 1. So this is equal to -1 times 1 all over sine squared x. And this is -1 over sine squared x. This is negative sec squared x. Alright, so you try y is equal to e to the power x all over x squared. Alright, so all the functions that we've seen so far of the form y is equal to f of x, so it's easier to find the derivative, which is dy dx is equal to differentiate what you have here. If you differentiate f of x, you have f prime of x. What if y is not a function of x and neither is x a function of y? What if both are functions of another variable t? Okay, so we have y is a function of t, x is a function of t. Then how do you find dy dx? Differentiate what you've been given. And doing so, it means you're applying the rule called the chain rule. Okay, so you want to find dy dx, but y is not a function of x. X is not a function of y. So how do you find dy dx? Differentiate what you have been given. If you differentiate y with respect to t, then it means you're getting dy dt. If you differentiate x with respect to t, you are finding dx dt. How do I manipulate these two terms to get dy dx? Okay, what I have is dy dt. What operator do I need to bring here in order to get dy dx? It is dy. So if this is giving me dy, then it means what I will get from dx is divided by dx dt. Okay, so it means differentiate y divided by differentiate x. So differentiate this divided by differentiate x. Simple as that. So this is equal to dy dt times, it's the long division, so you turn it around, which is dt dx. All right. Example is if y is equal to 2t plus 1, x is equal to 2t minus 1, then dy dx is differentiate this with respect to t. So if you differentiate this with respect to t, you get in 2 all over. If you differentiate this with respect to t, you get in 2. So this is equal to 1. Another example, if y is equal to cos of 2t, x is equal to sine of t, then dy dx is differentiate this. So if you differentiate the cos of 2t, means you're differentiating the number or the function after the cos. Differentiating 2t with respect to t, we get 2. Differentiating cos, we get negative sine 2t. All over differentiating sine t with respect to t, we get cos of t. So this is equal to negative 2 sine 2t all over cos of t. All right. So we've looked at the quotient rule, the chain rule, and they are all of the form y is equal to either f of x, that we want to use either the first principle or we want to use the sum and the difference rule, that is if I have plus or minus g of x. Okay, then I can use the sum and the difference rule. You notice that it's always of the form y is equal to something which is in terms of x. Okay, y is equal to a function which is purely in terms of x, or y is equal to a function which is purely in terms of t, x is equal to a function which is purely in terms of t. Okay, all these functions are called explicit functions. You have one variable on one side is equal to another function. So these are called explicit functions. However, there are some functions that is not easier for you to break it into the form y is equal to f of x. Such functions are called implicit functions. Okay, example is if you have xy plus sine y is equal to x. It's not easier to form a function out of this, of the form y is equal to a function which is purely in terms of x. It's not easy to find that. You can take y to one side and then the other side will just be purely in terms of x. Okay, if you have such a function, then it means that function is called an implicit function. So if you have an implicit function, then to differentiate it, we use what we call the implicit differentiation. Implicit differentiation simply means that when you differentiate a function, indicates that you have differentiated the function. How do you indicate? It means if you differentiate x, indicates that I've differentiated x with respect to x. If you differentiate y, indicate that you have differentiated a y with respect to an x. Okay, so let's use that same example. Xy plus sine y is equal to x. All right, first term is a product of two functions. So if you have a product of two functions, then what do you use? The product rule. And what does the product rule say? It states that keep the first constant or keep the second constant. Any one would do. So if we're keeping the first function constant, then it means we multiply it by the product of the second function. So we keep the first function constant, differentiate the second function. If you differentiate a y, you get what? 1. Because y is to the power 1. Using the product rule, multiply the product. So you multiply the index by the y. So you have times y, 1 minus 1. So 1 times y to the power 0. Y to the power 0 is 1. 1 times 1 is equal to 1. So if you differentiate y, you get 1. But because it's an implicit function, after differentiating, you indicate that you have differentiated a y. So since I differentiated y, I indicate that I have differentiated a y with respect to an x. Okay, it's a product of two functions. So if you're keeping the first constant, differentiating the second, it means you have to add the reverse to it. And the reverse is keep the other function that you differentiate constant. So since we kept constant the x in the first term, it means you're keeping y constant in the second term. So keep y constant, differentiate x. If you differentiate x, you get 1. So times, because you are differentiating x, we indicate that we have differentiated an x with respect to an x. Okay, plus we go on to the second term, which is sine y. If you differentiate sine, what are we getting? Cos. So we have cos of y, indicates that you have differentiated a y with respect to an x. And this is equal to differentiating x, we get 1 times, we indicate that we have differentiated an x with respect to an x. Okay, so simplifying, we have x dy dx. Dx is equal to 1. Just like h over h is equal to 1, dx is equal to 1. So you have 1 times y, which is y, plus cos of y dy dx, and this is equal to dx is 1. 1 times 1 is 1. So simplifying, since we want to find dy dx, it means we group dy dx. So we have x dy dx plus cos of y dy dx plus y is equal to 1.